All right, we're on.
Perfect.
All right. All right. So the z-score is 1.645 for 90%.
Yep.
What was it again?
The z-score is 1.645. So the equation
T90.
And square 25.
Okay, so the margin of error is z-score times the standard deviation divided by the square root of n.
Did you get 16.45?
What? I haven't done it yet. So 1.645 is the z-score. So it's going to be that times. All right, so square root of 5.
So it's z-score times standard deviation, right?
Oh yeah, so it is 1.645 times 10.
Divided by the square root of the population.
Well, that's already, so square root of 25 is 5, and 50 divided by 5 is 10. Because you have the standard deviation divided by the square root of n times the z-score. So it's 1.645 times 10, which is 16.45, so Mike was right.
Yeah, so it'll be 16.450.
Oh, yeah, good call.
Yeah.
Yep.
Well, that's for
Good
number
save.
4, right?
That's
No,
for
it's
3.
Wow. Yeah, I didn't quite get this lesson.
So there's just a lot of different equations that we have to remember.
That's what
So the margin of error is m, and m equals the z-score times the standard deviation divided by the square root of n.
Okay.
Yeah, so all you do is you enter the 0.9 up in your normal probability applet in the area, which is the center highlighted.
Mm-hmm. So for 4,
And this is just going to be, is this plus or minus that 526? Is this how that works?
I think it's actually just 526 because that's the point on the line that we're using. Let me see. So in the political poll, the point estimate for the Republican candidate is 49%. The point estimate gives a specific value as an estimate of a parameter.
Oh, you're reading out of the textbook.
Yeah. So I think it's just 526 because that's our point on the line. Because in the book, they gave the example
Sounds
of
correct.
they gave the example of the Republican candidate was 49% and the Democratic candidate was 51%. So the X would have been that 49 or the 51. So I think for 4, I think it's 526.
Okay.
So the margin of error is that same equation we did in 3, except now we're using the z-score for 95%, which is 1.96, right?
Yeah.
Yes.
All right, so we do 113 divided by the square root of n, which is 8. So it's 14.125 times 1.96.
So that's 27.685.
Well, I think we have to do the 27.685 plus and minus. Or no, I guess that is. No, you're right. That is the margin of error because m equals that equation. So margin of error is that 27.685. The lower limit of this confidence interval would be 526 minus that.
Yeah.
$498.315.
Yep, that's what I got. And then 5.
And then 553.685.
Yep, that's what I got.
What would happen to the width of the confidence if the sample size increases, the width decreases? Because the higher the sample size, the closer it gets to the middle.
Yeah.
Okay.
If she changed it to a 99% confidence interval,
It increases?
it's in the book. They have
Yeah,
the
I'm
same
looking.
question.
Increasing the confidence level will lead to larger values of z. If z is increased, then the margin of error would increase. So it would lead to a wider confidence interval.
What section is that in the book again?
4.2 factors affecting width of confidence interval, and then they ask a question if it increased
yeah.
from 95% to 99%.
Yeah, so increasing the confidence levels will lead to larger values. So the margin of error would increase. If z is increased, the margin of error is increased.
Yep.
But that.
So
for 9, they're talking the width of the confidence interval.
So
right, that was for 9. Is it'll increase?
Oh, it'll increase as well. Okay.
So, oh man.
8 might be something different.
No, I think it's the same thing. Oh wait, no, sorry. What would happen if the sample size is increased? Then the square root of n would increase and the fraction would decrease, which would lead to a smaller margin of error. Yeah, so 8 we have decrease and 9 is increase.
Okay.
Yeah. All right.
Bright Bulb Light Bulb Company.
Sample size I need.
So this is where it's n equals the z-score times the standard deviation over the margin of error, and that's all squared.
Yep.
All right, so z-score is 1.96 times 400 divided by 50. Square that.
983.
I got 246.
Ooh. What did I do wrong?
So let's try that again. We do 1.96 times 400.
Yeah, that was my bad. I did that wrong.
784 divided by 50 gives us 15.68. Squared is 245.86, but we round up, so 246.
Yep. Apparently I pressed the plus button, and so it added the answer for the 1.96 times 400.
Awesome.
You got 246.
Yes.
Yep, that's right.
Okay, and you said you got that by doing 1.96 times 400.
Because it's z-score times standard deviation divided by the margin of error, which is 50.
Right.
And then you square that answer.
Yeah. Okay. Yeah, just double checking. So I got 245.86. So round that up.
Yep.
Okay. Main side.
All right, so I'm thinking that for this we use the mean salary for women's, which is 111,000, and subtract 36,730 from that. Is that right? Oh, wait, no. We have to do another calculation. We have to find the margin of error.
I don't even know.
Would you have to solve for it?
I think so.
In this one, we have to solve for the margin of error. Or wait. No, the standard.
So we need to the first thing we need to find is the margin of error, which is there's so many stinking equations here. Margin of error is z-score times standard deviation divided by square root of n. So z-score is 1.96. We need to do
Times 36,000.
yeah, so 36,730 divided by 6, because that's the square root of 36. I've got too many calculators open.
Times the z-score. So it's 11,998.46 continuous.
Uh-huh.
Let me check. So 36730.
So I think that we then take that x, so x is plus or minus the thing, so the lower range, 101,000 minus 11,998. 11,999, I guess. Or I guess no, because we round up the other part. So
Just leave the decimals, and then we'll round at the end. That way.
yeah, yes, that way we don't mess anything up. So 99,002.
Yep. I think.
What I got.
Probably.
What would you get? 99,000?
99,002.
The upper limit is same thing, just with adding it.
Yeah, I hope I didn't delete that one.
It's 122. 998. $122,998.
999.
99.
Because you always round up.
Is it? Where does it say that?
It says round to the nearest whole number, but in the book it says, let me find this part. When doing a sample size calculation, you always round up.
Ah. Okay.
So that way you're guaranteed to have whatever part of the fraction there is.
Own section and everything. All right.
Yep. 5.1 rounding up.
Yep.
So, find my answer. What was it? 122,999?
Yep.
Okay.
This book is trying to give me a virus.
Confidence.
So it's A simple random sample was drawn by the population.
That X is normally distributed,
It's all of the above, isn't
and
it?
that
'Cause it
standard
says-
deviation is assumed to be known.
It says the 3 requirements needed, and there's only 3 answers.
Yeah, but those are the right answers. I just checked in the book. So X bar is normally distributed. We know the standard deviation, and it's drawn from a simple random sample is drawn from the population. So that is it.
Nice.
I will go ahead and submit. And we got 100.
Nice.
Sweet.
Yeah, thankfully this lesson wasn't too bad.
For
Probably-
some reason, when I was reviewing, it was way harder in my head. Like, I don't know what was going on.
Hopefully Thursdays will be
Yeah,
not crazy.
Yeah.
I'm kidding.
All right. Well, thanks, guys.
All right.
Thank you.
Bye.
Yeah.
Good night.
See you
Thanks for
guys on
posting,
Thursday.
Tyler.
Yep, no problem. We'll see you guys.
Yeah.